if the left side expression equals right side expression. On the left side, we have tangent of x times cosine of x, and on the right side, we have sine x. So first, I'm going to replace this tangent of x using the trigonometric identity. That is tangent of x. This equals sine x over cosine of x. So let me replace this tangent of x as sine x over cosine of x, and we have this cosine of x, and on the right side we have sine x. We now see that we can cancel this cosine x in the numerator with the cosine x in the denominator, so we only have sine x, and this equals sine x, and this is always true. So we see that this left side expression equals right side expression when we use this identity. Tangent of x equals sine x over cosine x, and this means we choose the option tangent of x equals sine x over cosine of x. We now verify if sine 2x over 2 sine squared x, and this equals cotangent x. And to verify this, I'm going to use the one of the double angle identity. That is, I'm going to replace this sine of 2x using the double angle identity. That is sine 2x, and this is identical to 2 sine x cosine of x. So let me put that, or I replace this sine 2x as 2 sine x times cosine x, and in the denominator we have 2 sine square x, so it will be 2 sine x cosine x divided by 2 sine square x. On the right side we have cotangent x. We now simplify the left side expression. We cancel this 2 and 2. Also this sine x, we can reduce this sine squared x. This power will get reduced by 1. So basically we have, on the left side we have sine x divided by sine power of 1x, which is sine x, and this equals cotangent x. And we know that cosine x over sine x, this is one of the identity, and this equals cotangent x. And this means we replace this left side and left side expression as cotangent x. On the right side we have cotangent x, and this satisfied, or this is true. So we have utilized this double angle identity to verify this left side expression equals right side expression. That is sine 2x equals 2 sine x cosine x. And this means we choose the option B. That is the correct answer. We now determine the solution of this trigonometric equation where x is from 0 to 2 pi, 0 is included and not the 2 pi. So we have this expression, that is cosine of pi by 6 plus x, and then we have another expression plus sine of pi by 3 plus x, and this equals 0. So to solve this equation, I'm going to use these two sum identities, that is cosine of a plus b equals cosine of a cosine of b minus sine of a times sine of b. And similarly, sine of a plus b, and this equals sine a cosine of b plus cosine a times sine of b. So first, let me use this uh, cosine of a plus b. I can apply it over here. So I consider a as pi by 6 and b is x. And similarly for the sine, I consider a as pi by 3. So just write down on top of it, and then b is x. So first, let's apply the cosine of a plus b, which is cosine of a. That is cosine of a is pi by 6 times cosine of b, which is cosine of x, minus sine of a. That is a is pi by 6 times sine of b, which is sine of b is x. So we are done with this first one. Now we are going to apply the sine of a plus b to expand this expression. So I put plus here. So sine of a plus b is sine a cosine b. So I write down sine of a, which is sine pi by 3, times cosine b, which is cosine x, plus cosine of a, that is cosine of pi by 3, times sine of b, that is sine of b is x, that is sine x equals 0. So let's simplify this. We can put the values, that is standard values for sine pi by 6, cosine pi by 6, sine pi by 3, and cosine pi by 3. Uh, these are some standard values which are available from the table, or we can also utilize the unit circle values. So we have cosine of pi by 6, and so this equals cosine of pi by 6 is root 3 by 2. We then put cosine x times cosine x minus sine of pi by 6, which is 1 by 2 sine x, plus we now put the value of sine pi by 3, and this is root 3 by 2. We then have cosine x, so multiply by cosine x, so it becomes root 3 by 2 cosine x plus cosine pi by 3, and this equals 1 by 2 times sine x equals 0. So let's see if we have some like terms and we can add or subtract them. We see that we have a positive half sin x. We also have negative half sin x. So these two gets cancelled, and we have these two terms, that is root 3 by 2 cosine x plus root 3 by 2 cosine x. So it will be 2 times of root 3 over 2 cosine x, and this equals 0. So we can cancel these two 2's, and so we get root 3 times cosine x, which is root 3 cosine x. This equals 0. We divide both sides by root 3, so we only get cosine x equals 0. So this is the trigonometric equation which we have to solve now. This can be solved using the unit circle. We know that from the unit circle, at x equal to pi by 2, cosine of x is 0. This is 0 comma, we will have sine of pi by 2, it's basically 0 comma 1, as well as at x equal to 3 pi by 2, cosine of x is 0, so this is 0 comma sine of 3 pi by 2, it's negative 1. This coordinate is 0 comma 1, and this coordinate is 0 comma negative 1. So we know that cosine of x is 0 when x equal to pi by 2, as plus when x equal to, this is pi by 2, as plus when x equal to 3 pi by 2. Only for these two values, that is when x is between greater than or equal to 0 and less than 2 pi, as it is given in the question, that is x ranges from 0 to 2 pi. So in this interval, we only have two values for x, that is x equal to pi by 2 comma 3 pi by 2. The cosine x is 0, and this means we can choose this option D, which is correct for this and question.